Hello. In this video, we're going to be looking at another double angle trig identity. This time we're trying to find the cosine of 2x, or moreover, we're trying to put cosine of 2x in terms of values like cosine of x and sine of x that we already know. Now, like in the last video when we did sine of 2x, what I'm going to do is I'm going to use our angle addition formulas to turn this into, well, not to turn this into cosine of x plus x, that's what it already is, pretty obviously. But I'm going to use our angle addition formulas to take x and x and then separate those out into some other expressions. So this is going to give us cosine. Actually, you know what would be better? I'm just, because, some review wouldn't hurt, I'm going to write the formula, the angle addition formula for cosine out. So the cosine of some angle alpha, which is going to be x in this example, plus some angle beta, which is also x in this example, is going to be equal to, and this works for all angles, as I'm sure you know, not just angles that are identical. This is going to be equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Seems simple enough. Let's use it in our formula. So this expression here, our value cosine of x plus x, is going to be the same as cosine of x times cosine of x, right? Cosine of b and cosine of a are both going to be cosine of x in this example. So that's just going to be cosine of x times cosine of x, and then minus sine of x times sine of x. Isn't that funny? Now let's simplify this out a little bit. This is going to be the same as cosine squared of x minus sine squared of x. Now, this is, in some cases, a good enough answer, but there are ways that this is simplified that are going to be more useful. So I'm gonna underline this because this is our answer for now, but there are more useful and actually more commonly used solutions that involve different ways of simplifying this. So basically what we're going to use is the Pythagorean identity, or moreover just the Pythagorean theorem for trigonometry, which is just that sine of x squared plus cosine of x squared is equal to 1. Or we can write this in two different ways, or two other ways that we'll be getting into. This is going to be also that sine squared of x is equal to 1 minus cosine squared of x, and that cosine squared of x is the same as 1 minus sine squared of x. And basically what we're going to do is just plug some of those in so that we can simplify what we have here so that it's only in terms of cosine or sine, because we might have either one and need to solve this problem for whatever reason. The reasons do vary. And often, as we'll see in calculus, this is going to come up more in terms of integration, which we're not doing right now. But it's a good thing to know in general, just as a way of understanding how trig works. It's quite fascinating, and as we get into proofs with angle addition and things like that, this might become more clear. So cosine squared of x minus sine squared of x. Well, let's just plug something in for cosine squared of x first. We'll just plug in, right? Cosine squared of x is equal to 1 minus sine squared of x. So what's that going to give us? This whole expression here is going to be the same as 1 minus sine squared of x minus sine squared of x. All right, that's the same as 1 minus sine squared of x, and then minus sine squared of x again, so that's the same as 1 minus 2 sine squared of x. And that will be one form of our identity. besides cosine squared of x minus sine squared of x. So now we have two forms, and I'm going to circle it in white, just like we did with the other one. So what's the other form? Well, we can just replace sine squared of x instead of cosine squared of x. So sine squared of x is equal to 1 minus cosine squared of x. So let's just plug that in. So we're going to have, where can we put this? Here, I'm going to make some space. I think the angle addition formula has become clear, so I'm just going to erase that. You can always go back in the video if you want to get that down. So we're plugging in our formula here for sine squared of x. We're going to have cosine squared of x minus, what's sine squared of x? 1 minus cosine squared of x. So this minus distributes out, and we're going to have cosine squared of x minus 1 plus cosine squared of x. Those cosine squared of x's combine, we're going to have 2 cosine squared of x minus 1 as our third form of our original cosine of 2x up here. So all of these values in white, and actually between, are equal, but the ones in white are the ones that you should definitely remember, especially this one at the bottom. As we're going to get into in a couple of the next videos, this will be pretty important in the power reducing formulas, and in my opinion, probably one of the most useful of these formulas. Certainly my favorite of these formulas, just because of how it can be changed around in terms of cosine of 2x, but that'll be for another video. Thanks for watching.